Hello, my name is Zachary Chenoweth, and this is my presentation of Lab 1 for control of mobile robots. For Lab 1, we have 4 tasks that we need to complete. For task 1, we are supposed to have our robot move in a straight line x distance in inches in a y seconds. So for this example, we're going to have x be 10 inches, which is about the length of the edge of one tile, and y will be 15 seconds. Here we have a function called setSpeed, which basically calculates the velocity in radians per second of our given time and distance requirements. So we take the distance divided by the time, which will give us inches per second, and then we divide it by the radius of the wheel in order to turn it into radians per second. Here we have an if statement, which is used to check if the move is possible. And the way it checks it is it sees if the velocity that we calculate is greater than the wheel's max velocity, which is 6.28 radians per second or 2 pi radians per second. In our while loop, we have a variable called time passed, which keeps track of the amount of time has passed since the start of the simulation. Here we have a few variables and a print statement in order to print the values so that way we can plot the values later in Excel. And here we have an if statement where it says that if the time passed is less than our desired time, then we want to set our wheel's velocity to the calculated velocity from the function I mentioned earlier. Else, if the time passed becomes greater than or equal to our desired time, then we want to set the wheel's velocities to 0 to stop it. Now that's basically the code, so now let's see the program run. So again, we have our desired distance as 10 inches, which is about the length of one tile. You see the robot starts moving. And then once it's completed its motion, it stops. And here we can see that in 15 seconds, our robot has moved about 9.983 inches. Now, because we are stopping based on time, this number will be slightly off. It will not be exact every time. So for our next task, we have to turn the robot in a certain amount of degrees in a desired time. Here is the code for that. All this code up here is generic functions and stuff for the robot to actually run and be able to run. This will be the same in all of my code. Here we have x, which is our desired distance in degrees, and y is our desired time in seconds. This function calc velocity, all it does is it calculates the velocity in radians per second that we want to set our wheels to. The way it does this is first it finds the circumference of the circle drawn if the robot were to spin in place and do a full 360-degree loop. The formula for that is 2 pi times the radius of the circle, which in this case is 1.14 inches. Then we take our x degrees and divide it by 360 and multiply it by the full circle the circumference that we found earlier in order to get our distance to travel this many degrees. Next, we find the velocity in inches per second by dividing the distance by our desired time. And then to get it into radians per second, we have to divide it by the radius of the wheels. And then the function will return this velocity. Our next function is actually setting the velocity of the wheels to the velocity we calculated in the previous function. So first we have a variable that calls this previous function, and then we set the wheel's velocity. Now, because we want it to turn in place, we're going to have our left wheel turn in a clockwise motion, and our right wheel turn in a counterclockwise motion, hence why we have a negative velocity here. Here's another if statement that checks if the move is possible, and it does this by having our calculated velocity and checking if it's less than half of the wheel's max velocity. Now, the reason we want it to be half the wheel's max velocity is because when the robot turns in place, if the velocity is too strong, the wheels will tend to slip, making the value that the sensor is reading higher than it actually is. So we found that if we take half the wheel's max velocity, it will be smooth and the transition and it'll be a lot more accurate. In our while loop, we have a few variables in order to print out the values in order to graph them later. Here we get the IMU value for yaw, which is the degrees that the robot turns. And we're subtracting 180 by this value in order to set the range from negative 180 to 180, which is what the IMU is defaulted at, in order to get it to 0 to 360 degrees. Here we have our if statement where it basically says if the time that has passed in the simulation is less than the desired time, then set the speed of the robots by calling that function that I showed earlier. Else, if the time desired is met, then we want to stop the robot by setting its velocities to 0. And then we break from the loop. So that's all the code for this task. Now let's see it run. So for this example, I have it set so it will turn 720 degrees or 2 full circles in 10 seconds. So here we can see the robot has made 1 full turn. And then finally 2 turns and then it stops. Again, like the previous example, because we are stopping based on time, the robot isn't going to exactly stop at the desired thing. It'll be slightly off by a few decimal places. Our next task is to trace a rectangle. Now, in order to do this, we have to have the desired height and width of the rectangle, which are placed here, the desired time, which is in seconds, and the desired velocity we want the robot to be moving. Now, all these are interchangeable, so that way when the lab is being evaluated, these numbers can be changed easily. This function, calculate time, will calculate the minimum necessary time in order to complete the rectangle that we desire. In order to do this, we take the 2 times the height of the rectangles divided by the velocity we want, plus 2 times the width divided by the velocity, plus the 4 corners, since we have to stop and turn, will give the robot 1 second per turn. And then we return this time. This function, like the previous tasks function, will calculate the velocity in radians per second. And we do that in the same way. So we find the circumference of the circle. We find the degrees and multiply it by the circumference. we divide the distance by the time, and then we divide that value by the radius of the wheels in order to get in radians per second. And then we return the velocity. This function handles all the parts of the rectangle that move in a straight line, so each of the sides of the rectangle. Here we have a variable to keep track of the start time for when the robot is about to make the move. And then we have a variable called stop time, which is the amount of time the robot should take in order to complete that one move. Here we have a while loop and a variable called time passed. So we take the current robot time and subtract the start time. And we say, as long as the time passed is less than the stop time, then we are going to have the robot move in x velocity divided by the wheel's radius in order to get it radians per second. Else, if the time passed is greater than the stop time, then we're going to set our robot's velocity to 0 and then break from the loop. This next function is to handle the turns on the corners. Again, like the previous function, we have a start time where we take the current time and hold that value so we know when the robot started this movement. In our while loop, we have a time passed variable, which takes the current time, subtracting the start time. And as long as our time passed is less than 1 second, then we are going to set our velocities by calling the function that I had mentioned earlier. Else, if the time passed is greater than 1 second, set the velocities to 0, and then break from the while loop. Here we have a few if statements to check if the move is possible. The first check we have is if the calculated time is greater than the desired time, meaning it will take more time for the robot to do the movement than we are trying to get it to do. The other check is if the wheel's max velocity, if the desired velocity that we are trying to go for is greater than the wheel's max velocity. Now we have to multiply it by the wheel's radius because this wheel's max velocity is in radians per second. So if we multiply the wheel's radius, it puts it into inches per second. Here in our main while loop, we call those functions that I mentioned earlier in succession. So we have the first height. So the robot will traverse the first height, then stop. Then it'll turn 90 degrees. Then the robot will traverse the width, turn 90 degrees, traverse the height, turn 90 degrees, width again, and then turn 90 degrees back to the starting position where the robot began. Then we have a print statement that'll print the amount of time it took the robot to complete this task. That's all the code. So the example that we have is we're going to have our robot traverse a rectangle of height of 10 inches and a width of 20 inches, which is about the height of 1 block and the width of 2 blocks. So it's going to trace this rectangle right here and then stop where it started. Well, let's go ahead and see the rectangle run. And as you can see, our robot was able to complete the task in 19.232 seconds. And it generally traced the rectangle that we desired. Now again, because we are stopping based on time, some of the angles and the stop time are slightly off, but not by enough that is significant. Our last task is to trace a circle. here we have the desired radius of our circle that we want to trace in inches. And here we have the desired time we want it to complete this circle in. This function right here will get the radius of the outermost circle. So in order to complete this task, what we have to do is we take our circle that we want to traverse. We have an outer circle for the left wheel to traverse, which is a larger circle than the one we want. And then the right wheel is tracing a smaller circle of a smaller radius. So for our left circle, since it's bigger, we're going to find the circumference of this larger circle, which is the radius of the circle we want, plus half of the length between the wheels. So if the distance between the wheels is 2.28 inches, half of that is 1.14. And then multiply by 2 pi to get the circumference. Then we want to calculate the velocity that we need. So we take the distance that we want to travel, or the circumference of this circle, divided by the desired time to get inches per second. Then we want to turn it into radians per second, so we take that velocity and divide it by the radius of the wheels. And then we return the left velocity. This function here does the same thing, except it's for the right wheel. So instead of adding half the length between the wheels, we subtract it. Again, we find the circumference, divide the circumference by the desired time, and then divide it by the radius of the wheel to get it in radians per second. And then we return that velocity. Here we have an if statement to check if the move is possible. The two checks that we have are if the left wheel is greater than the max wheel's velocity, and the right wheel if it's greater than the max velocity. In our while loop, we have a time passed variable that will keep the current time of the simulation. We have variables here to get the position of the wheels as it's going through to print them out in case we need them later. And then we have an if statement that says if the time passed is less than the desired time, set the velocities of the left and right wheel by calling their respective functions. Else, if the time passed is greater than y, then set the robot's velocity to 0, stopping it. And then we break from the loop. Now that we've seen the code, let's see the robot run the circle. So in our example, we want it to run a circle with the radius of 10 in 25 seconds. Now, the radius of 10, again, is about the length of one edge of the block. So the circle that we want to trace is going to be in between these 4 blocks here. As you can see, the robot is running along fine. And then once the robot gets to the starting position, it stops. And like the previous example, because we are stopping based on time, the values might be slightly off by 0.1 or so inches. And as you can see, we have traversed the circle in 25 seconds. And that is all the tasks for Lab 1. Once again, this is Zachary Chenoweth presenting Lab 1 for Control of Mobile Robots. Thank you.